All right, hi everyone, I'm April. So, a little bit about PARI, a little more in depth. I am a volunteer at PARI, and this is going to be my preface to this entire presentation. I am an astronomy enthusiast. I am not an astronomy professional. I do hold several degrees in marine biology and horticulture. This is my hobby. This is what science geeks do for their hobbies. So I'm going to go through this information. If you have a question that I can't answer, understand that I am a volunteer, that I've taken classes, and that would be a great opportunity for us to take a note and go to Google and figure out the answer. All right? So PARI, a little more in-depth history. So PARI was created in the 1960s as a way station for satellites and for the manned missions around the Earth and to the Moon. So before we had a satellite network, you had to have a ground station every so often to get the telemetry of what was going on. Once it passed out of that line of sight, it was handed off to the next station. So we were the station on the East Coast. They installed an array of radio telescopes to help gather the data. And there were several milestones that happened at PARI. The very first call from space to the Earth was at PARI. The very first photograph of the Earth taken from space, looking back, we received and interpreted. So that lasted for maybe into the 70s, late 70s, early 80s. By that time, band, the really bright band of the Milky Way across the sky. That's why there is a lot of stars and a lot of activity. However, so we're basically seeing most of the Sagittarius arm and a little bit of everything else. Absolutely everything you see in the sky, by and large, except for 3 or 4 exceptions, are in our own galaxy. In the winter, we are, if you see where we are here, we're looking tilted towards the Orion Spur. Now, of course, you're looking through a lot less of the galaxy. However, we are so close to this arm, that's why the stars appear very crisp, clear, bright, closer, more intense, because we're getting a snapshot of the material that is closest to us. So, we got what a galaxy is. Anybody have questions about galaxies other than physics? What I'm going to do now is take you through many of the different objects that we can observe in the sky, and I'm going to tie them all together and give you sort of a family scrapbook or a photograph book of what it is to be a star, to be born, to die, etc. I'm going to start with this, not really something that we see very often, but rather don't see. So when I'm talking about all the material in the spiral arms, there's a lot of hydrogen, it's a lot of dust, it's a lot of gas. And when that dust and gas clumps together and has no light source to light it up, this is how it's going to appear. This is not something that most people really look for in their telescopes unless they're like really intensely about looking through telescopes at interesting things. I'm starting us off here because I have to find, it's a cycle and I have to find some point to start. So this is, we're looking, let's say we picked a portion of a spiral arm in the Milky Way, and we're black patches. So that is simply the density of the gas and the dust obscuring the background behind it. It has no light source, it is not illuminated, so it is dark. This has nothing to do with dark energy or dark matter. This is still visible light range, it's just blocking everything. So we get into what happens when these regions of gas and dust light up. There are many different reasons why they would light up. So we're right here, we're unlit, we're not making any babies, we're not making any stars. These clouds, these interstellar clouds are going to become stellar nurseries. And what usually happens is a nearby star has gone supernova, a nearby star has become a white dwarf, 2 supermassive black holes merged and created a lot of gravitational waves. There's many different things that are going to disturb this gas cloud to get it to the point where it is hot enough, because this is extremely cold, obviously, it's space, but it has to get hot enough and things need to get near enough for them to start aggregating and clumping and creating stars. So once that happens, there are two ways I'm going to discuss that they can be lit up. These H2 regions, H2 is simply ionized hydrogen. Once the dust and gas and particles start condensing, they get hotter and hotter and tighter and denser and denser. we're still talking, many years, thousands, 10,000s, etc., into millions. But they're gonna, when they go supernova, it's a vast expanse of energy that is released, which will continue to churn this cloud and make more and more babies. Another way that it gets started, I kind of touched upon this, is nearby stars can illuminate from within, or they can illuminate nearby. But either way it happens, that's when we are able to see it. That's when that dark cloud becomes illuminated and it becomes something interesting for us to look through the telescope at. So once all the material has been used up and many stars have died and pushed stuff out and cleared out the gas, this is what's left over. And eventually they make their way to other dark areas, or even areas of active star formation. More winds, more perturbations, more energy, more movement in general is going to start that cycle over again. Yes?
Is a shooting star a dying star?
No, that is, a shooting star is a meteor. So meteors are tiny fragments, which kind of important, they're tiny fragments, size of peas and smaller, grains of sand, by and large, is going to be what a meteor is. And it's burning up when it enters the atmosphere. So little tiny dusts, and that is important because those tiny dusts could be in our nebula, in our gas lanes, in our H2 regions, in our star formation areas. And then as they would connect together, they would cause density and become a star. But if they found their way into our path, the reason they're in our path usually is because they are the dust left over from a comet passing us. These comets pass either regularly or sometimes just once. But the showers, like we just had the Perseid showers, that is a specific comet that comes every so often. And that dust trail, that debris trail just stays there. And we pass through it regularly. Yes?
So this huge fireball that we saw this past week shooting through the sky,
right,
is the size of what?
No. The majority of shooting stars are size of sand, rice, etc. Fireballs tend to be ever so slightly bigger, not by much, not usually. Yeah, well, think about it, just a regular shooting star, that's a grain of sand. It doesn't take much more to really beef something up. Any other? Nope. Where was I? Oh yeah, so like I said, it's all one big cycle. Some of the really interesting nebulas that we can see, something that's actually you can see with the naked eye, if your eyesight's good enough, when you're looking at Orion, and he has his sword coming off his belt, yeah. In the middle of that sword, if you look at the star there, it's fuzzy. Take a look, binoculars. Honestly, you can see this with binoculars. Binoculars are a great observing tool. I do recommend sitting yourself down and propping yourself on something if you don't have a stand, but just get out your, just whatever binoculars you have. I'm sure you all have a pair of binoculars living in this area. There's lots of things to see. Direct it at the sky. Pick any point in the sky, especially when you can see the Milky Way. Travel up and down the Milky Way. You're going to see interesting blobs and bits. It's part of these things that I'm talking about. But in the belt of Orion is the Orion Nebula. You got the Horsehead Nebula and other things clustered there together that are so big and so bright and so close that you can see it with the naked eye. It's fuzzy. So, touch briefly upon a couple of the other things that you can see in the sky, because this actually kind of completes the cycle. The planetary nebula and the supernova remnants, these are two things that when they happen are going to send out energy, send out heat, send out waves, send out material that will start this star formation, keep it going, and keep the cycle. A planetary nebula is this is a snapshot of what our sun's going to look like by and large when it dies. Planetary nebula is a misleading name. It is nothing to do with a planet. It's in astronomy, a lot of things were named a really long time ago before we knew what was going on, and they're just intractable about changing names. So what it is when a solar mass equal to ours, up to 8 times the size of us, when it gets near the end of its life, it's going to go supernova, yeah, and it's going to swell because of the pressures, and I'm not getting into the pressures that keep a star fueled. That's a whole other lecture. But as it starts to run out of energy, it starts to run out of its fuel, it no longer has the hydrogen to combine, it starts to expand. And it will swallow Mercury, it will swallow Venus, it will swallow Earth, it may or may not get all the way to Mars. And then eventually, it'll blast off all of the gas and molecules and energy that has kept it together, and this is the remnants of it. And they come in different flavors, because just because it's blasted off, those planets, like some of the outer planets maybe, some of the moons, some of the remnants of the rocky things inside, if we're talking about our solar system in particular, can still orbit and trail and mix it up. So this is what happens when a star dies, becomes a white dwarf. These are visible for I want to say 20,000 years or so. It's a big number of time that it's visible for. A supernova remnant, so supernovas is what happens when a star dies and it is over 8 times as big as, more than 8 times as big as our sun. These only last for a couple hundred years. It's so big, so violent, so full of energy that it dissipates very, very quickly. Much more intense explosion. And the energy, the waves, the particles that it sends out reach a bit further, trigger star formation in different clouds. Definitely affects the local neighborhood. If a star were to go supernova within a certain range of us, it could potentially, if not certainly, end life on Earth. It could strip away our atmosphere. Luckily, none of the candidates that are going to go supernova that we can see, that we can observe, that we have tracked. It's not going to happen anytime soon. But that's the difference. Is that far away? I mean, our nearest neighbor is 4.2 million light years away. And if that went supernova, it would definitely kill us. But it's something, I don't know the number off the top of my head. It has to be really, really, really close in astronomical neighborhood. Most everything else is so far away from us that it's not going to impact us. But it is interesting to think about. And whenever I see an article saying, is Betelgeuse going supernova, et cetera, et cetera. Now, Betelgeuse wouldn't affect us, I don't believe, even if it were to go supernova. But it's always a little terrifying, like, ooh, hope not. When stars go supernova, they are visible during the day. Stars go supernova in other galaxies, and that galaxy is overshadowed by the immense energy output. So, I mean, we have plenty of historical information. The Chinese were very, very accurate at keeping logs, different areas in Europe, etc. There are plenty of times where you would be able to read a book by the light of the star of the supernova at night. You would still be able to see it during the day. So but that brightness, that's not going to last very long, like weeks, months.
Would it look like a point of light in the day? Like
it would be brighter. It would be brighter than the moon is in our sky at night. So think of when you see the moon during the day, think of that just like ratcheted up and maybe more diffuse because it's not a solid body. Last thing I'm going to talk about is nothing to do with the life cycle, kind of, sort of. I just threw it in there because it's a really, really easy thing to find. Everything that I've just talked about, low power telescope with enough dark sky, you're going to be able to find these and see these. The Orion Nebula, I live 1 mile from downtown Charlotte, and I can see the Orion Nebula through my, I think it's a 5-inch telescope, cheap telescope. So, globular clusters are collections of stars that are very, very old. And referencing back to this initial structure where I said we have our galactic bulge, our record, we also have this is a globe that goes all the way around us. And this is where you're going to find the globular clusters. They're low energy, they're very old, and we're not 100% sure what they are or how they got there. The prevailing theory is that when two galaxies merge and everything gets mixed up, they're like the droplets that get ejected when you pour one liquid into the other. And they're just hanging out there. Yeah, a splash. So that this may or may not be the splashes left over from it doesn't necessarily have to be merging, just interacting. We're interacting currently with several small galaxies. So we think that's what happens there. They're really, really fun objects to look at through a telescope, and that's about it. So we're going to switch topics over to our solar system. Does anyone have any questions about stars, nebula, star formations, star death? Yes.
Magellanic clouds, that sort of thing?
The large and small Magellanic clouds are not, they're not globular clusters, they're actual dwarf galaxies. And for those of you who don't know what he's talking about, the large and small Magellanic Clouds are nearby very, very tiny galaxies that can be seen with the naked eye in the southern hemisphere. Yes?
Did you say we could see a globular cluster with a telescope or binoculars somewhere nearby? Is it, do you know where-ish we would look? Is it in a constellation or?
There are many, many, many of them. There's just so many of them. I would recommend downloading an app called Stellarium. And I can leave app information. I'll leave something with them.
That directs you.
It does direct you. Yeah. So I know there's Skywalk and Star Map and all these other things where you hold it up and it identifies things. Stellarium is a lot like that. It's just what most of the professionals use as the particular app. That has a lot more information about the object. You can put an object in and get a lot of information about it, and it'll show you where it is. It'll triangulate you to it. So it's very handy. Yes?
Relative to other stars, are we tiny, modest, medium-sized?
Modest to medium. The majority of the stars in the universe are red dwarfs. Red dwarfs are, so you know how I said that these big, massive, supersized stars burn out very quickly? Red dwarfs last for trillions of years. That's with a T, trillions of years. We are somewhere in between. Our galaxy, our solar system, our star came into being roughly 4.5 billion years ago. We are about halfway through our lifespan. So we've got another 4.5 billion years to go. There was a hand over here? No? Okay. I imagined it. Did that answer your question? Okay. Okay. Solar system. This is my jam. This is what I'm the planetary science geek of our little group. So we have the inner planets and the outer planets. That's the first designation of dividing up our solar system. We have the asteroid belt. All the planets that are interior of that are the interior planets. All the planets outside of the asteroid belt are the exterior planets. The interior planets are all rocky planets. The outer planets are all gaseous or ice planets. And there's Neptune. So Neptune is a rocky planet. Pluto. My bad. Pluto is a rocky planet. It doesn't follow its little buddies over here. So just like the galaxy is that big record player, our solar system is on the same plane, the same record. All the planets are by and large lined up, and they all go around together. If this is the plane, let's say my thumbnail is the sun or whatever, Pluto's orbit goes like this, completely cattywampus to everything else that's going on. Not only that, Pluto has a lot of buddies made of the same material with the same extremely cattywampus orbits. And that is why, though it is one of the most fascinating planets, dwarf planets I should say, that is why it's no longer a traditional planet. The upside, I was going to get the Pluto thing out of the way, because I know someone's going to ask. The upside of Pluto becoming a dwarf planet is that in the asteroid belt, Ceres became a dwarf planet as well. It's a sizable chunk of rock that is the things you need to be a planet. You need to be large enough that you have become a round spherical shape. You have to get to a certain mass before physics makes you round. You have to be orbiting the sun. The astronomers didn't even say a star. They said a sun, our sun, meaning like anything that's orbiting any other star, technically not a planet because it's not around our sun. I have a lot of feelings about this. And then, we can tell. and then the next thing the last thing you need is you need to have cleared your orbit, which I think is BS, because Jupiter has these sets of asteroids called the Trojans that orbit on either side of it. There's a lot of reasons why. I get it. So Pluto crosses Neptune's orbit. At a certain point. Although, why that means Neptune gets to remain a planet if it hasn't kicked Pluto out of its orbit, I don't know. But either way. So in its downgrade from planet to dwarf planet, it simply at this point leads the pack for all of the Kuiper Belt objects. It is, so we have the rocky planets, asteroid belt, gas giants or ice giants. Everything else from here out to a certain point is the Kuiper Belt objects. Beyond that, say they stop at the Turkey. Then it's mostly empty space, a couple things floating around. And then there's the Oort cloud in the parking lot. The Oort cloud, so the Kuiper Belt is like the asteroid belt. It's a belt. The Oort cloud is spherical. It surrounds us entirely. The Oort cloud, first of all, the asteroids and the Kuiper Belt objects, which are really just slightly different asteroids, all of that is remnants left over from when the solar system was created. It's building block material and various evolutions of maybe it was at one point part of a planet that got broke apart, maybe it never got combined with anything. So it's just leftover Legos that didn't get to be part of the playset. Pushed way out there, all that Oort cloud material just was blown away, probably during the different evolution creation of our star. Different solar winds came out and pushed everything out. That is where comets are born. All these perturbations I've been talking about, these waves, this energy riding along when things happen, such as supernovas, creations of black holes, etc. It'll agitate one of those objects, and it'll start. Those objects are at the balance point. If the sun's there and they stepped this way, they'd fly off into space. If they get pushed this way at all, they start to get sucked into the sun's gravity well, head in, and boomerang out. Any questions about the makeup of the solar system? Yay, planets! Mercury. Mercury is, now that Pluto's gone, is our smallest planet. It's only slightly larger than our moon. Cool things about Mercury. It does have a substance that would be considered an atmosphere that is made up. You would think the solar winds would just blast it all away, but it holds on to a little bit of gases. And when it's on a certain portion of its rotation and you look at it in a telescope, it has a tail like a comet. That's the sodium being burned off and blasted off. Mercury is very hard to visit. It's very hard for us to get spacecraft and probes there because it's so close to the sun that you got to speed up, because that guy is going around the sun every 88 days. If it weren't going that fast, it would fall into the sun. To avoid falling into this massive thing, you have to go really, really fast to keep that momentum up, yeah? So we have to go and catch up with it and hook around it to do any sort of orbit. So it's one of the least studied planets. It does have ice. Tops and mainly around areas, the poles, there are certain craters that the sun never peeks into, ever. There's still ice there. It has no moons of its own. That's Mercury. Any questions about Mercury? Venus. Venus is called our sister planet. It's only ever so slightly smaller than us. It itself has no moons. It rotates on its axis backwards, so to the point of how things rotate, how do galaxies rotate. The Earth rotates counterclockwise. We all go around the sun counterclockwise. This guy rotates clockwise. It is contrary to everything else. We think that it must have had an interaction with some sort of large object, especially towards the beginning when the solar system was getting all shuffled out and was being made, that spun it backwards, knocked its clock so hard that it spins backwards. The surface of Venus is highly, highly volcanic. There are just so many volcanoes on Venus. And that contributes to its cloud cover. Venus is called the dawn star, the evening star. Anything interior of between the sun and the earth becomes anything beyond us is an easy situation to see. It rises, it goes this way. But these planets have to be lit by the sun for us to see them, and at certain angles for us to view them through our amateur type telescopes. It's not very fun to look at through the telescope, in my opinion, because it is the third brightest object in the sky. So you have the sun, you have the moon, and then you have Venus. The reason it's so bright is not necessarily its proximity to the sun, but its cloud cover. It's very reflective, makes it very bright. You would think Mercury, being close to the sun, would be the hottest thing in our solar system. It is not. The hottest thing is Venus. So it used to have water, it used to have oceans, etc. But as the volcanic activity kept happening, created more and more cloud cover, more and more greenhouse gases that kept the heat trapped inside. The hotter it became, the denser the air pressure is. So currently it's 900 degrees Fahrenheit on the surface of Venus. That's hot enough to melt lead. The air pressure, 90 times that of Earth, is what you would feel if you went a mile below our ocean. So it's not really move-in ready. In the upper clouds, it rains sulfuric, it's acid rain. Doesn't reach the ground, but it within the clouds. It's under there are a lot of attention's being paid to Venus recently, due to the fact that they have discovered, they think, goes back and forth. They may or may not have discovered certain chemicals that are byproducts of, typically the only way we find them on Earth is they are byproducts of life. It is not inconceivable that there would be microbes and other small life forms that live in the clouds. On Earth, there are microbes and small life forms that live in our clouds, which not a common thing to know. But so It is possible, but the debate rages back and forth on whether they've really seen it, whether that's really a true sign of life. We have several expeditions that are headed to Venus in the next few years that is going to shine more light on it. Not that it needs any more, it's very bright. Mars. The most visited. I mean, if we haven't visited the moon as many times as we've visited Mars, as far as human presence goes, it still kind of blows my mind. Mars is super cool. It's quite small though, and I don't think people really get that. It used to have oceans like Earth. It used to have a very similar climate to Earth. But to hold on to your atmosphere, you have to have a magnetic field. Magnetic field is fueled by the dynamo that is the center of our Earth. The metal and the solid metal and the liquid metal that rotate around create a dynamo, and that's what creates our magnetic field, and that's part of what holds on to our atmosphere. Not only that, but it cools. If a smaller body is going to cool off a lot faster, it's going to stop that dynamo action. It's part of the reason why Earth is so warm is we have a lot of radioactive elements that are still warming us internally. Mars lost all that fairly quickly. So it has a very thin atmosphere. It does still have some ice that's seasonal. These ebb and flow. It's got some really great features. It's got a freaking canyon that you can fit the United States in. It's got a shield volcano, which is the tallest mountainous thing in the solar system. Also, if you're on the surface of Mars, it's not really red. It's kind of tan, orangey. Think our Southwest. The reason it looks reddish is because things are, there's constantly dust storms, things are getting kicked up, and when you have those layers upon layers upon layers in distance, it looks a little red. I still think it's kind of orange. So, I skipped over Earth on purpose. We're going to talk a little bit about why the study of Mars and the study of Venus are so important. So the Earth has natural periodicity of climate change. Our last ice age ended roughly 25,000 years ago, and we are currently in a warm interglacial period. But the temperatures are rising without anything in particular natural source. So the reason that we go through these periods of heating and cooling is due to our plate tectonics. It's due to what's underneath the surface. It's due to things moving around. It's due to volcanic activity. There's no volcanic activity, and the plates are shifting around, and we're not all separated out like this, but more of a Pangea togetherness that's going to create different cycles in our oceans, which is going to vastly, vastly affect our temperature, our climate at that time. Then all of a sudden something shifts, the magma pops up, it's pumping out a bunch of, basically all the gaseous release from a volcano is going to be greenhouse gases. And that starts to warm us up. The rate at which we are warming cannot be attributed to anything that's happening inside the Earth or naturally. So the reason why, how to tie this to astronomy is that we look at Venus and we look at Mars as models to compare to Earth. Mars is a story of a planet that used to be Earth-like, that used to have the right temperatures, used to have water, used to have an atmosphere, used to have a water cycle, And then Venus went the other direction. Mars got cold, Venus got hotter and hotter and hotter. The runaway greenhouse effect, Venus is the poster child for the runaway greenhouse effect. So trying to understand the evolution of those planets can help us more accurately understand the climatic changes of our own planet, of the general evolution of our planet in comparison to these other planets. Venus is the way it is because it's 96% carbon dioxide, its atmosphere. That's a lot of greenhouse gas. All right, before we move on to the outer planets, any questions?
Someone recently said that our orbit is getting closer to the sun. Is that true or not? How does one respond?
I mean, there are things, my response to the level at which I'm educated about these topics is that the mass of the sun changes ever so slightly. All those perturbations and different external pressures that I was talking about change things. The solar system is not a static place. It's a dynamic, living system, basically. And changes in gravity, it could, yes, but that it's not at this point, to the best of my knowledge, that is not what is affecting things. So our sun is going to continue its life and it's going to cool. It's also going to get a lot hotter. Something I didn't address when I was talking about all of this is the Goldilocks zone, the habitable zone. Earth is in the habitable zone. Every star has, at some point, whether it's really, really far out because a big hot star, or really, really close in because it's a tiny little red dwarf, has a habitable zone where water can exist as liquid. If you have that water that can exist as liquid, water is what we believe is the medium for the evolution of life. That is what's going to create, if it's of a certain size, like the Earth is, to hold on to its heat, then it's going to hold on to its atmosphere. So this zone is what we target and look at for the potential for exoplanets or any planet that is not within our solar system, for the potentiality of life on those planets. As our star changes and evolves, that habitable zone, that Goldilocks zone, is also going to change. So I said that the sun is going to swell out like that, yeah? Well, if the new leading edge of the sun is here, what do you think happens to these planets? Right. So as the star's changing and going through cycles, it's going to shift that habitable zone around a little bit. It's going to make us more squarely in the middle, maybe closer to the hotter edge, the cooler edge. So once it becomes a red giant, some of these outer, it won't do it, it'll just blow the gas away from the gas planets. They'll just probably be, by and large, dissolved. But their moons are rocky, and so they'll heat up. In fact, spoiler, we'll move forward a little bit. Neptune has a planet called Triton, which we believe might be a really, potentially, once it starts to heat up, a potential awesome fallback base as we're trying to figure out what to do as the sun's. There will probably be water. It'll have an atmosphere at that point, most likely, especially if we help it along with terraforming, etc. So. To answer your question, I don't necessarily know, but I can explain to you why those things would happen. So So here's another option, and I'm sorry, I'm going way down this rabbit hole to end your question on. If you take a very large asteroid and throw it just right to where it loops around the Earth, and we're talking about much more technology than we have at this current time, you could shift the orbit of Earth ever so slightly. And if you did it for long enough, you could move that planet. Every time we go around, every time we send a spacecraft out and we loop and do that gravity assist around Jupiter, what we're technically doing is stealing some of its energy that keeps it going around the sun. That's what a gravity assist is doing. We're stealing a very small fraction of that. So with that in mind, we could potentially reposition the Earth. So it'd be like getting on a plane and chasing the everlasting sunrise. We would just keep shifting it to stay in that perfect sweet spot of the habitable zone. So when you hear about companies with mining opportunities, going out and pillaging the asteroid belt, maybe flinging those asteroids back towards the moon so that we can harvest all the precious minerals. The upside of that is if we learn how to do stuff like that, we can also potentially mold the solar system into a more human life-friendly design.
Or mess it up some more.
I'm not in charge of the science. I'm just letting you know the theory. Yes?
Do you have any idea how long it took Mars to go from like we are now to not being inhabitable?
Unfortunately, no. I don't. That's just not a date that I happen to have off the top of my head. While we were still boiling, another reason why we're habitable is because of our sizable moon. Most likely what happened is while the inner solar system was sorting itself out, pre-planets are planetesimals. So we were sizable, and then something maybe the size of Mars got chucked at us for whatever reason, smashed into us. Everything, the material from the moon heated up, the material from us heated up, and then slowly coalesced and congealed. We were very, very hot for a very, very long time, which is why part of the reason why we're still holding on to our internal warmth. When we were still a boiling nightmarescape, Mars was already kicking around with oceans and hanging out. So, Jupiter. Jupiter is one of the most fun things to see through a telescope in our night sky. Even with binoculars, if you look long enough and stay still enough, you can see the 4 Galilean moons. These Galilean moons are so called because Galileo jury-rigged the first telescope to his designs and looked up and he's like, what the heck? So they're called the Galilean moons. They're the 4 largest. Again, 1 mile from downtown Charlotte with a 5-inch telescope. If that great red spot is facing towards us, you can see it. If one of these moons, sun, is passing here, you can see a dot. It looks like a tiny little felt black marker on the face of Jupiter, live time. Well, we just talked about how fast the speed of light travels, so let's really not get into that, but cool things about Jupiter. Jupiter is obviously our largest planet. It is a gas giant. The scope of how incredibly big it is, this is trying to make you understand the scale, but really think of it this way. If Jupiter had been much larger, it would have been a star. So some astronomers call it a failed star. It just didn't quite meet the mass ratio, the mass threshold, I should say, to ignite. It's really freaking big. That's my professional opinion. Great red spot, 3 times the size of Earth. But something most people don't know, it wasn't always there. It's like 350 years old. It could dissipate. It could reform in a different spot. A second spot could show up. We don't know a whole lot about the atmosphere, the different layers of atmosphere and how they interact. But the really exciting thing for me about Jupiter is the Galilean moons. Oops. Io is the closest end of the Galilean moons, and it is like Venus, just a great big old volcano mess. Which when Voyager, the Voyager spacecraft went by and we saw it for the first time, we're like, oh, well, there you go. We just didn't know that anything else had active volcanoes in our solar system. The last 3 of the Galilean moons are ice moons. And the really cool thing about it is that we know Europa, we're pretty sure Callisto and Ganymede all have global oceans. So space is really, really cold. Our moon, as warm as we are, no longer has any internal temperature, yeah? The fact that these moons, this one has so much heat in it that it still has lava enough to flow through, that's a lot of heat. These 3 global oceans, they have an icy crust, but on the interior is water. The reason those things can happen way out, because it's a lot colder out there, is because of the mass of Jupiter. Jupiter is so big that as these moons rotate around it, there is tidal flexing and stretching. And just as anyone knows, when you rub something and move something, it's going to get hotter. So that's why they have any heat whatsoever. Io has enough heat to be volcanically active. Europa definitely has a global, more confirmed than these, but we're very certain that it has a global ocean. The reason that's exciting is because life most likely originated on Earth at the bottom of the ocean. Everyone know what the black smokers are? You see them on the National Geographic, billowing. That's billowing, spewing out building blocks of life. Then you have a medium, such as water, and you have heat. It's kind of what you need. You need energy, you need the building blocks, and you need, we think, you need a liquid to swim around in. So at the center of these is not just nothing. There is some sort of rocky cookie core. Potentially there are black smokers. Potentially there is life, be it small or large. Can you imagine being let's go total geek sci-fi on this. Can you imagine being a civilization that was evolved to intelligence in an ocean world that's completely dark, and then you get enough technology to drill a hole up and like, oh crap, what's all this? What's going on here? Okay, go back. Multiple spacecraft headed out to these to specifically study these. NASA has the Europa Clipper that will be launching soon, specifically just to spend all its time looking at Europa. We have had the Galileo spacecraft, Juno spacecraft that was observing everything, but this is specifically just for this bad boy. ESA launch JUICE, which is Jupiter, icy moon, something, 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 to study all 3 of the icy moons. So, pretty exciting stuff. Any Jupiter questions?
How big are those moons compared to Earth?
Ganymede is the largest moon in the solar system, much bigger than the moon. These 2 are smaller. I think this one might be moonish size. I'm sorry, I don't know off the top of my head. I do know that Ganymede is pretty substantial in comparison to our moon. Pretty sure Europa and Io are smaller. Saturn is super cool as well. So, Saturn is composed of materials that are lighter than water. So if we could conceivably get a large enough vat of water, Saturn would float on it. Saturn and its iconic rings, it's a very fun object to see through the telescope. I think that's one of my favorite things I do at PARI is when people see Saturn for the first time and they invariably a curse word comes out of their mouth. And then there's a little kid, they're like, oh, sorry, but did you see this? So it's pretty fun watching people get to see it for the first time over and over again. The rings of Saturn, it's got 82 moons that we know of. I'm sure there's more. It's got a lot of moons. Now, Jupiter's no slouch, but we know of slightly more moons of Saturn. So what most likely happened to create these rings is one of its moons, those perturbations that move things around, got kicked a little too close to the mass of Jupiter or Saturn, and it pulled it in, crushed it up, and that's the beautiful rings. It's just dead moon. And the other thing to remember is in geological, astronomical time span, these rings are actually quite young. There were dinosaurs that roamed the Earth that, had they evolved to create a telescope, would not have seen the rings. Yeah, it's really, and we don't know exactly how long they're going to last, but there will be one day where that material will dissipate, either be burned up by getting too close or kicked out, and it won't have the rings anymore. But it does have a lot of other fuel for more rings potentially. All right, so the 2 moons I'm going to focus on for Saturn are Titan and Enceladus. So when Voyager, I can't remember if it was 1 or 2, was passing Saturn, it noticed something strange coming off of Enceladus. Enceladus is another planet, or another moon, and it is quite small. It is a quite small little thing. But it has a global ocean and it has geysers that shoot that ocean out into space. So every 10 years, the big astronomy muckety-mucks get together and lay out a plan for what the next decade should look like in space exploration. There's one specifically for stars and the universe as a whole. And then there's one specifically for our solar system exploration. So 2 of the things that came out of this, it just happened, I think this year, maybe late last year, is that Enceladus is one of our number 1 targets to send something to. It's like next up on the list. Because why go, we think Europa, there is a possibility that Europa has active geysers as well. But we know for certain that Enceladus does, and you could just fly something straight through it. We did when we sent, which one was Saturn, guys? Help me out. The spacecraft. I can't remember. The spacecraft that we sent that's been a long time going around Saturn actually did fly through the water and was able to figure out what its components were. And that is how we know that there are a lot of building blocks for amino acids, i.e. life. Titan is the only moon in our solar system with an atmosphere. It's really, really cool, guys. Okay, so it has its own atmosphere. Its atmosphere contains a lot of methane. It has a lot of greenhouse gases up there kicking around. We think that we are, with a high degree of certainty, that it has a methane cycle, just as we have a water cycle here on Earth, that there's liquid seas, rivers, ponds, whatever, of methane that evaporates, makes clouds, then it rains methane again. Yeah. The Huygens probe, which was attached to that, I'm just drawing a blank. Cassini! Thank you. So, Huygens probe was attached to Cassini, and as it was flying around, it disengaged and landed on the surface of Titan. It was designed to float. The only spacecraft that has ever made it to the surface of Venus, much the same. It didn't last very long because, again, 900 degrees Fahrenheit and a mile under the ocean. But we make them because we don't know what to expect. We anticipated there being liquid down there, so we made it able to float. If you look at the NASA website, you can see a time-lapse video of the pictures of the landing. We did not land in water, but we are going back there very soon. There is a project called Dragonfly, which inspired by the results we've been having with the Ingenuity helicopter drone thing on Mars. We're going to send something that can set down, sample, pick up, fly, set down, sample. And we're sending that to Titan. So when it comes to potential life in our solar system, the order of importance is usually Mars, that we might find. Mars, we're looking for remnants of life. So Mars, and then it's a toss-up between those icy moons and Titan, because we use Earth as a model for how we interpret everything else in the universe. So there are certain microbes that are known as extremophiles that can live in crazy cold temperatures. They can live in such hot temperatures. The iconic hot spring there at Yellowstone that has all those pretty colors, those are extremophiles. That's what gives it that color. There's life in there. They can live in lava, by lava, extreme acid, extreme alkalinity. So if that can happen on Earth, we think it would be possible, maybe, for something like that to happen on Titan. Uranus. It is one of my favorite planets, mostly, and notice I pronounce it Uranus. This is why it's pretty much my favorite planet, because, right, you're watching the National Geographic whatever special, and you're like in this guy's deep voice and is talking about, and then we come to the king, the giant of the planets, Jupiter, and blah, 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 blah. Saturn with its iconic rings, blah, 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 blah. There's Uranus. On to Neptune with blah, blah. I'm like, dude, that's a whole planet. Like, you can't give it 15 minutes? Come on, guys. One of the reasons why it is treated that way is because it does not have a lot of internal heat that we know of. Therefore, it doesn't have a whole lot of the cool cloud structures and striations and formations that are going on in Jupiter and Saturn and even Neptune. This guy had, just like Venus, had some sort of weird impact earlier on in its life because it rotates on its side. It rolls along its rotation. So sun, one pole, my elbow is the other pole. So So either its ass or its head it's facing the sun, and it's just rolling around its orbit. Funny little guy. We do believe there is actually more cloud structure and formations, but simply that because of the way Uranus is, we can't see past the top layer. The second thing on that decade-long, projection, it is also, Uranus is slated as top priority to get a mission to, which makes me happy. Fun fact about Uranus, because I gotta sell Uranus to people. It doesn't sell itself. It rains diamonds on Uranus. So storms happen at the top. You got graphite, you got carbon, you got a lot of different things going on, and when they get superheated, they get denser and they start to fall towards the gravity center. These gas and ice, this is an ice giant. Jupiter and Saturn are gas giants, but just because it's ice doesn't mean it's got like glaciers that you can land on. All of the gaseous ice giants don't have a surface mass. It doesn't have land that you can land on. So if you get heavier up in this atmosphere and you start to fall, it's going to get denser and denser and denser. So just as Jupiter is a failed star, the reason stars ignite is because they get so dense and so hot that they combust, they ignite, they start to have fuel, they start to fuse elements. It's not to that point with any of these gas or ice giants, but as that's falling down, it gets compressed, and guess what it gets? It becomes a diamond. It's just freaking raining diamonds on Uranus, and you guys don't even care about it. Like, you don't care about this planet at all. Don't even know how to say its name. All of the gas and ice giants have a ring. Obviously, Saturn's is the most interesting, but Jupiter, Uranus, and Neptune also have rings. And ending the show with Neptune. Neptune has this storm, the Great Dark Spot, because astronomers are very, very imaginative and innovative with their naming schemes. So I already gave away its pretty cool fact that it has this big old moon that could be, at some point, I'm not sure it would ever have an atmosphere that we could breathe, but it would be a nice fallback point when the sun starts to get hotter. But just like Jupiter, this storm has been going on for a while. In fact, this one is much newer. It fades, it comes back, it reforms. It's not as stable as the Great Red Spot, but it's pretty. So, missions to the planets. Brief overview. So Galileo and Juno went to Jupiter. Cassini-Huygens went to Saturn. New Horizons, super, super fun mission that was kind of like the Voyagers 1 and 2, where we just chucked a spacecraft past the planet. We didn't go into an orbital insertion. Made it to Pluto and just blew our minds. Those first pictures back from Pluto, we had no idea. So the point of the Voyager 1 and Voyager 2 missions were the planets were aligned close enough together to where we could slingshot from one to one to one and visit them all, with the exception of Pluto, because it's weird, okay? It's just a weird orbit. So we weren't able to get by Pluto. And this guy, we had a stamp series where it was each planet and the date it was first explored, and Pluto's stamp said not yet explored or something like that. He's like, I'm going to change that. So very, very interesting stuff that we learned about Pluto. Europa Clipper, I mentioned that briefly. That's NASA. So Jupiter Icy Moons Explorer, that's the JUICE ESA. It has just launched recently. But the funky thing about space travel is the Europa Clipper that will be launched years later will actually make it out to Jupiter first. So I'm done. This has been long, and I'm sorry. I'm sorry this has been